everyone, welcome back to the channel. I'm the GCSE Science teacher. In today's video, we're going to be studying moments, gears and levers for GCSE Physics. So if you do enjoy this video and you want more GCSE Science content, please feel free to check out my other videos. I'm a real life science teacher and I do teach biology, chemistry and physics at GCSE and biology at A-level. So feel free to check out my videos on there. I also have an Instagram and TikTok. Everything is at the GCSE Science teacher. So feel free to join this community of scientists and hopefully you will find this useful. Thank you so much for your support. So what is a moment? Now you might be thinking of a moment where you just have a moment where you look out into the horizon and you just take in the lovely view. That is not what we're talking about today. A moment in physics is actually a turning effect of a force, and that's a kind of key definition you need to be aware of. And actually lots of different products will actually utilize moments, and we can calculate moments as well. So gears and levers, perhaps in a bicycle, in doorways, those hinges that help you open and close a door, all of those different devices actually utilize this idea of a moment. And we're going to be able to, like I said, calculate moments today. A moment acts about a point. Often it's called a pivot or a fulcrum, and essentially this helps that object to rotate in some way, either clockwise or anti-clockwise. And again, we're going to talk more about the calculations now. But if you want to, you can actually demonstrate moments right now if you're watching this. So if you have a door in your house or you have a door nearby, you'll be able to actually see how this works. So what you need to do is you need to open the door and you want to push the door open with your finger, just one finger like this. Push the door closest away from the hinge. So as you can see in the image here, you can see the doorknob is furthest away from the hinge. The hinge is often just attached. That's the pivot part. If you try and push the door open, you'll find that it's much easier to push the door open the further away you are. However, if you try again to push the door open closest to the hinge, you'll actually find it's really difficult. Have a go at it and see how it goes. Let me know in the comments below. So how do we actually calculate moments? Well, you need to know the equation. M, which is moments in Newton meters, is equal to the force in newtons times the distance, which is in meters. Now remember, the distance is actually the perpendicular distance from the pivot, because actually sometimes we know that the object is going to rotate, but you need to know it's the perpendicular distance. So if they give you a diagram or something like this, you will be able to see the perpendicular distance because it will be at right angles to that force. They often will just give you the information in the question, but just be aware it's the perpendicular distance that you're looking at. Now, with any calculation in science, and you may know this from previous videos of mine, I always say this: if you type it, you must write it. Don't cause yourself to get less marks if you accidentally write the wrong answer and you've put all that hard work into the calculator. Write it down as well. It does happen. I've definitely marked mock exam papers where students have accidentally written the wrong number or they've rounded incorrectly. Definitely write everything down that you put in your calculator. It's so important. So let's have a go at an example and see what we get. So the force of 50 newtons is exerted onto a spanner that has a bolt that it's turning, and the distance is 20 centimeters. Calculate the moment of the force. The first thing you want to do is identify that distance is in the wrong unit. It's in centimeters when it needs to be in meters. So what you need to do is you need to divide that by 100 and you get an answer of 0.2 meters. Now you can put the numbers into the equation. So write your equation out. M equals F times D. If you put your numbers in, you'll see that you've got 50 newtons. That is times by the distance of 0.2, and that will give you 10 Newton meters. Don't forget to write your units, underline the answer, and you should be good to go. Let's have a look at another question for you to have a go at. It says the force is now 72 newtons and the spanner is still turning that bolt. The distance is 20 centimeters again. So it's just a new force. Same idea. Have a go at it. Write down your answer in the comments and I will put the solution in the description box for you as always. So what happens if the moments are balanced and the objects are balanced? What do we do in that case? Are there questions like this? Well, yes, there are. So if an object is balanced, the total clockwise moment is equal to the total anti-clockwise moment. And we can use this idea to actually work out missing information. So we're going to go through an example that will hopefully clarify a few things. So two friends are playing on a seesaw, which you can see over there, and the girl has a weight of 500 newtons and the boy has a weight of 650 newtons. I must just say at this point, the weight is the force, it's not the mass of these children, just in case anybody's looking at this and like, how is a child 650 kilograms? We're not talking about kilograms. Remember, that's mass. We're talking about the force due to gravity. So this is newtons, okay? So just be aware of that. Mass and weight are not the same. Did a video on it. I'll link it for you in case you're not sure. But just to clarify. So you can see they have different weights in this case. And if they sit at the same distance from the pivot, the moments will be on true. If you've ever sat on a seesaw with someone else, you'll notice that actually someone may be heavier than you or lighter than you or whatever. And this actually can mean that there's kind of like an uneven balance. So what to do to get them the even way, you actually need to sit either closer or further away from that person to kind of balance out the force that's acting. And that's essentially showing moments as well. So that's what's happening here. So if they sit at the same distance from the pivot, the moments will be unbalanced. So if the girl sits 2.4 meters away from the pivot, the center bit, calculate the distance the boy must sit from the pivot in order for the seesaw to be balanced. So what we're going to do, just like before, we're going to calculate the moments of what we can. So we know we have the information for the girl. So we're going to do force times distance for the girl. So that'll be 500 newtons times by 2.4. And this will give us an answer of 1,200 Newton meters. Now we know that, as before, the total clockwise moment and the total anti-clockwise moment, they need to be equal if they're balanced. So we can say the moment of the boy must be equal to the girl in a balanced situation. However, we don't know what the distance is for the boy. We can't work out the moment yet because we don't have that information. That's what we're trying to do. So what we need to do is rearrange this equation of moments to get that information on its own. So get the distance on its own. So we have, in this case, the moment divided by the force, and that will give us our distance for the boy. So the moment that we have is 1,200 because we've just worked that out for the girl. They have to be the same for it to be balanced, and we're going to divide it by the force of the boy, which is 650. Now if we calculate this, we get an answer of 1.85, and because it's distance, it's measured in meters, so that's the answer we'd give. For you, have I got this? It says now calculate the new distance the girl needs to sit away from the pivot when the girl's cat sits on her side of the seesaw. The cat has a weight of 75 newtons. Again, I will leave the answer in the description box for you, but do have a go. I'd love to hear from you. So last but not least, then we have levers and gears. Levers work by allowing a larger force to act on the load than is supplied by the effort. So it is easier to move large and heavy objects. Essentially, you could apply a very small force to move a really heavy load. And this is helped by the distance. So I've got an example here. We've got a spanner. In fact, we've got two spanners. One is smaller and one is larger in length, and it's so much easier to use the longer spanner because you've increased that distance, meaning the moment is greater. Remember, moments is equal to force times distance. So the longer the spanner, the longer the length, the easier this is to actually rotate and to move. The same can be said for gears. So gears are essentially found in loads of different objects that have turning cogs, which you can see here, and all that needs to happen is you'd have a smaller cog working with a larger cog, and their teeth, those little protruding bits, they will actually connect inside one another and they will help them to rotate. So where the gears meet, the teeth must both move in the same direction, and this causes them to rotate in the opposite directions. So you just need to be aware of the fact that levers and gears are key examples of where moments are found in different products. And that's it from me today. I've been the GCSE science teacher and you have been curious. If you did enjoy this video, please give it a big thumbs up, share it with someone else, and do subscribe if you haven't already. It'd be lovely to have you as part of our community. Thank you so much to everybody who has been so kind and supportive here on my channel and also on my other platforms as well, TikTok, Instagram. It's lovely for you to be finding these videos and finding them helpful. So thank you for all your really kind comments. If you did enjoy this video, like I said, there will be more coming out shortly. I'm aware that the exams are very soon, so I will be putting together some helpful last minute revision tips for you guys. If there's anything you specifically want me to cover before then, please do let me know. Like I said, I always cover biology, chemistry and physics here on my channel and my other platforms as well. But yeah, I hope you enjoyed the video and I'll catch you in the next one. Take care.